Let's take a look at another clue that mass spectroscopy gives us. And so this is the presence of an odd number of nitrogens. So if we have an odd number of nitrogens, we can tell from the mass spectra. So if you have one nitrogen, three nitrogens, five nitrogens, that kind of thing, we can tell from the mass spectra. And it's quite easy to tell. And that's if your overall mass is an odd number, you have an odd number of nitrogens, right? And so if your overall mass is an even number, you're either going to have zero or an even number of nitrogens. So that's the overall rule. If you're curious as to why, here's the reasoning why. You don't really have to know this all too well, but if you're curious, you can know why. So we can take a look at the mass of different components. So hydrogen, carbon, nitrogen, oxygen, chlorine, and bromine are going to be our most common compounds. And so we can take a look at their mass. Hydrogen is 1, carbon is 12, nitrogen is 14, oxygen is 16, chlorine is 35/37, and then bromine is 79/81. And so you can see nitrogen has an even mass number, and so it doesn't really make sense from that alone why it would cause the overall mass of the compound to be odd. So not only do we have to consider the mass of the compound, we also have to consider how many bonds it forms. And so hydrogen will only form one bond. Carbon will obviously form four. Nitrogen will form three. Oxygen will form two. Chlorine and bromine will each add one in general. And so then you can think about what kind of molecules it can make, right? So hydrogen can only make one bond. So it can either make an H2 or maybe like a CH. If you just put H's everywhere, you can extend it to the end. Carbon would make something like a CH4. Nitrogen would make an NH3. Oxygen would make an OH2. And then chlorine and bromine would each make HX. And so if you think about the mass of these components, now that they've been made into molecules, which is what we're studying, the masses here are 2, 16, 15, 18, then 36 and 38, and then 80/82. And so you can see the only odd number here is with this nitrogen, right? So now we're supposing that the hydrogens are directly attached to them, but you can try other thought experiments. It doesn't matter if you connect them with carbons or oxygens or anything like that. It ends up being the same story. And so what you need in order to make the overall number odd is that you need a difference, right? This number either has to be even or odd, and then this number has to be the opposite, right? If you notice nitrogen, it's the only one that has an even and an odd number, which will sum to be an even number or an odd number. If you take two even numbers, they sum to be an even number. If you take two odd numbers, they sum to be an odd number. You don't really have to know that too well. That's just if you're kind of curious. Really, all you need to know, if you see an odd mass, you've got an odd number of nitrogens. So for example, here we have triethylamine. So it's a nitrogen with three ethyls attached to it. And you can see that our molecular ion peak is right here at 101. This 102 is the M+1 peak. So again, odd mass means odd number of nitrogens.